all exponent rules. Remember, we're like, if you're multiplying, let me show you. Why am I just talking? All right, folks. So we're talking about logs again, and I want to remind you that logs are just the inverse of exponents. So in the same way we had x squared, we can have log with a base of 2. We can have a way to take the inverse of our exponents. And it's more specifically when we have an exponent that is unknown, then we use logs to figure it out. We use logs to figure it out. Now, some of the exponent rules you might remember is like this. When you have x squared times an x to the third, right? What do you do with the exponents? Remember how there's different rules where, like, if you're multiplying them, then you add the exponents, okay? In the same way, logs work the same way. This is how this rule works. X squared is x times x, right? X to the third is x times x times x. So altogether, we have x to the fifth. So the shortcut to this is to think, well, all you have to do is add the exponents together. And it's related in that same way, and in the same way that when we multiply, we end up adding the exponents. There's rules with logs that apply in the exact same way. Okay, so just keep that in mind. You've seen some of this before. Some of the rules are going to be very similar. As you can see here, that when we go through these rules, the laws, we have log base b of m times n. And what we end up with is log base b of m plus log base b of n. You see how it's somewhat related. It's kind of like adding the exponents when you multiply two exponents together. And we go down the list. If we have division, we end up subtracting. And this is called expansion. This is called expansion. When we go from here to here, that's expanding. And this would be condensing, going the other direction. So today, we're just going in both directions. The last lesson is how to actually find the actual exponent. But we basically manipulate it. We manipulate our logs using the log laws. And from there, we're going to be able to simplify things like this or expand things like this, right? Log of 4 times 3 is going to be the log of 4 plus the log of 3. Because the rule tells us how to go about expanding it, You guys can have open notes on the test, so just keep these notes. You just have to know how to actually apply them. So I'm not going to make you memorize all the log laws. But going through them, we could see that when you multiply two of the index values here, we end up adding. Whoops. When we divide, we end up subtracting. When we have this exponent, one of the index values has an exponent to it, we throw that exponent value out front. We got this weird situation where it's log of 1, and that gives us 0. Log of b, the reason why this ends up being 1 is because it is a b and another b right next to each other. So what this is saying is that b raised to the first power is b. B raised to the 0 power is 1. Okay. Now I want to review a little bit just from where we came from. So before we had this, let's say we had 5 and we have x. Okay. Now this is the base, right? And this is the exponent, right? Easy, base exponent. So if I'm changing this into log, I'm going back to the last lesson just to remind you kind of like what this is all talking about. If I want to find the exponent, I use the logs to find the exponent. So I make the exponent equal to the log of whatever the base is, right? And they would have given us an answer for this. Let's say it's 125. So we have this side, we have this exponent that we would really have to do more like trial and error. I'd have to plug in values for x to figure out what 5 raised to what power gives you 125. But using the logs, we're going to be able to do that, solving it, in essence, doing the inverse operation to an exponent. The inverse operation to an exponent is using the log. So watch. This is going to be 125. So what this is saying is I didn't know what the exponent was. I used the logs to figure it out. And the exponent is going to be equal to the log of the base, log base 5 of this index over here, the answer to the exponent answer. So let's see if we can do this one. Let's do it. Let's just do this kind of process again. How about if I have 16 is equal to 4 to the x? Now, does anybody know what that actual answer is? What do you have to put in for x to make that work? 4 what? Gives you 16? Alicia knows. 4 squared, right? 4 times 4. 4 squared gives you 16. Okay. But if we didn't know that, if this was like 3016, you'd be like, I mean, I can go forever and figure that out by just multiplying, but you don't need to. We would change this identifying the index, the base, and not that kind of base, and exponent. So when we change that, remember that logs, we're looking for the exponents. I say x is going to be equal to, and all I need to do is log base 4 of 16. So just reminding you what the last lesson was about, it's showing that logs are used just to find what the exponents are. It's used to solve and figure out what the exponents are. Okay. So once you get into this state right here, you get into this log form, then you start to use all the laws to actually find what x is. Today we just learned the laws. On Tuesday, we're going to apply that because at this point, we have it simplified enough and we'd use something called the change of base. Tuesday is only about the change of base formula. Today is about, we know how to get it here. That was the homework from Tuesday. This stuff is how we manipulate it and condense it to try to simplify and end up with something that we could do the change of base formula. Change of base is Tuesday. That's how you actually get a number. Today's like, okay, we got into the log form. Today is all the laws to make it simplified. Tuesday is change of base formula. Done with logs. We know how to use logs. Okay? It's actually a pretty straightforward thing. And you might look at you like, this doesn't even look like math. There's too many numbers. No, there's no numbers. It's like too many letters, right? It's too much. It's too different than what we're used to. But really, it's very similar to exponents, and it is, you'll see how it pieces together, actually. I think some of you will like it. Some of you won't like it. But let's see. I want everyone to go and copy this down, and then we'll just have some examples we'll go through. So go ahead and copy this. This is key. Anytime I put a key, that's just like a super important part to know. You can only combine logs with the same base. If base is not listed, the base is 10. The base is 10. Okay. And base 10 is like the basis for all of math. It's like when you get to 9, you get to 10, and then you put a new digit for the next place value. And you might say, well, what else is there? But there's entire math systems that are base 6, base 7. What's an example of how that happens? Maybe weeks. You could say weeks are a base 7 situation. So after you get through 1 week, you write 1 week, and then you keep going through the days. 7 days is 1 week. So base 10 is just the standard. If the base is not listed, it's a base 10. Okay, so that's key. So we're going to work our way through some of these, and remember today we're just converting we're just expanding, and then on the back we're going to have some condensing. Okay, so let's look at this right now. Let's look at expanding this number 1 here. So first off, you guys numbered the logs. Which law is this going to use? We have log of 4 times 3. The log of 4 times 3. And which law is this one going to use? Tell your neighbor. Tell your neighbor right next to you. And at home, you could tell me which law this is going to use. What do you think? Which law? Yeah. Good, I heard it. I'm going to go with it. No touching. It's cooties. I'm just kidding. Okay. Mostly just joking. All right, good. The first one, Taban, Alicia, Dave, all said the first. Anybody else? Nope. Okay, so log of 4 times 3 go ahead and just make an equal sign here. And this is equal to, looking at the first law, log base b of m times n is going to be log base b of m plus log base b of n. And again, we aren't told what the base is, so we assume, right here I can assume that this is a base 10. And if it's a base 10, you don't even have to put it. You don't even have to put base 10, because if it's not there, you know it's base 10. So this is going to be what? Log 4 plus log 3. Okay? Log 4 plus log 3. And once we get used to doing these, using the laws, then coming up on Tuesday, we'll be able to solve this out. And actually, you could solve this out, because now what do you know? Now you know you have a log button. The log button is automatically base 10. Log button right here. So look, I can go, I think I have to do 4 first and then log. That's an actual value. That's an actual value. Whoops. It's 0.602. Right? So now we can actually use, once we get into this form, then we can go ahead and we're going to use change of base for some things, but this is actually ready to solve this. Log 4 is 0.602. Log 3 is 0.477. So you just add those together and you would have the actual value for it. Okay, so that's where we're going. We're going to learn and use that log button on our calculator, and that's how we're going to get through it. All right, let's go ahead and look at the second one. And this one is aligned with the second law. So go ahead and try to expand that, and then tell your neighbor what you had, and just double check that way. Because I look at this and I see not multiplication. What do I see? I see division. So I want to think, well, what is division going to require me to do? Okay. All right. And tell your neighbor. Tell your neighbor. I'm going to expand it, so I'm going to end up with 2 logs, but something's going on between those logs. What? What is it? Okay, okay. Same thing? Yeah? Same thing all around? All right. All right. Let's see. Well, it's going to be 2 minus log 9. Log 2 minus log 9? Nice. Maggie, got that? Good? Yeah? Joshua, good? All good? All right. So I'm going to start just working through them pretty quick, because you can see that this is just going to be almost like, it's almost like you have a code here and you have to break the code and get into another form. So it's more like kind of that exercise. There's not going to be too much further we have to go today. So let's look at this one here. All right, this one's different. Here's what's different for number 3. It has exponents. So look at your laws. Which law is going to apply? Did I really just go? No, I didn't. Good. Yeah, number 4 is going to get even trickier. Number 4 is going to get trickier from here on out. But number 3 is going to help us figure this out. Okay. And check with your neighbor when you get it. Some of these are going to be really quick, right? Some of these you just have to move one thing. So if I look at law number 3, Law number 3. If I have, and again, don't worry about this B here, because all of our example problems down here have base 10, so we don't list the base. But if I'm looking up here at law 3, all I do is, whatever my index value is, if I have an exponent there, I just throw it out in front. Okay. So you can see we're just learning these slowly, because when we get down to solving, you want to be able to do all these as you go. 2 times log base 10 of 8. So log 8. 2 log 8 Easy. All right, this next one is meant to make you think about it. Let's look at number 4 here. Log of 1/2 raised to the third. So the 1/2, there's 2 laws involved with this. Log of a division and log of an exponent. Now remember that exponent applies to the 1 and the 2. So your final answer is going to end up with the number 3 2 times. Think about that. That's kind of like a hint on how that's going to work. All right. So we have these 2 things are going on for number 4. We have division and we have an exponent. So you're going to have to deal with those 2 things. And again, the 3, yes. And Tavon, distribute that 3. I like how you wrote that, Tavon. I'm actually going to solve it just like that. But I want you to distribute the 3 now. So I'm going to do this in a bunch of different steps. I'm going to do first, all you do is take the 3 out. 3 log 1/2. So you can work these out like on parts. And then what do I know? I know essentially it's 3 times, and what is log of 1/2? That's log of 1 minus, right? Log of 2. You see? So it's kind of like, we're working it out. We're using the laws and working our way through this. The last step I would say is to distribute. So 3 log 1 minus 3 log 2. That, Tuvon, is where I want you to go. But I like it. Tuvon gave me this idea to go here first. And I took your lead. So good job. Okay. And that's the hardest one we have to do on the front page here. Okay. How about this last one? This is the last one. Number 5. This one, you have to remember, when the base isn't given, what is the base? When the base isn't given, the base is 10. So now look at the rules and what law is going to help us there to figure out what is log of 10. Yes. So what is log of 10? So tell your neighbor or ask your neighbor if you don't know. You can show me on one hand. Yeah. I saw that and you were both right. What do you think, Joshua? Not sure yet. Okay, I'm going to write one thing here. Log 10 is the same as log base 10 of 10. Right? Because remember, this log 10 here is really log base 10, but if you don't see a base in there, it's because it's the standard 10. It's like x. You don't say 1x every time. You don't say 1 apple. You could say an apple. So the standard is log base 10. So here we end up with, what do you say? And it's kind of like a fraction. I mean, these interact in some ways like a fraction, but just in this case, don't actually follow that idea. Erase that idea from your memory. Okay. All right, thumbs up, sideways down for expanding. You see how the rules work together pretty well? Good, going good. Josh, how do you feel about this? Yeah? Okay, let's keep going. Because going this direction is expanding, and I think applying the rules the other direction is going to help us kind of get the whole big picture of it. This is where we're going to end up doing this one. What? Okay. But first, we'll look here. Okay. So I want you to now condense number 1, condense it, and the key here is that you have the subtraction going on, which gives you a hint. And then once you get it in the final form, I want you to reduce it as well. If you're not sure what I mean, you can ask your neighbor. What do I mean by your last step will be reducing it? What's this equal to? Log what? I'm going to give you a hint. It's going to be a fraction. And if I just go back to give you all another hint as well, notice how when we have division in our condensed form and go to our expanded form, the numerator on top is just the first value. Okay, so it kind of goes like in that standard, like top to bottom, left to right. And I like to point out those kind of spatial reasonings whenever I can. So this is going to be what? 6 over 3? And we can reduce that. Log what? Log 2. Whoa, couldn't see it. So what I did was, instead of log 6 minus log 3, it's log of 6 divided by 3. You can actually reduce this. 6 divided by 3 is 2. So we get log 2. You see, because this fraction right here, 6 divided by 2, we just get log 2. 6 divided by 3. Dang it, I keep saying it wrong. All right, how about this next one here? This one's related. Number 2 is related to one we did when we expanded it. It's a little bit weird. It's a little bit different. Okay, so number 2, the things that I'll point out for this one is it is subtraction. There's also this 2 out in front of both of them, and that's a key. That's a key. So what is this going to end up being condensed into one log value? What is it going to be? What you think? What you think? We just had a bird walk in and walk out. Wrong class? Okay. Birds aren't in math 3. That's cute. It has a little bird this big. Tiny bird. Okay. Yeah, tell your neighbor on this one. Check with your neighbor for sure. I know that it's going to have a log. It has subtraction, so there's going to be some division. But there's going to be one other aspect to it. Yeah. So you're right if you had log 7 and 3, but where does that 2? Where's the 2 going to go? How do numbers end up being in front of the log? They start as an exponent, and that brings it out in front. Now, we did one kind of like this. We did this one like this. Where'd it go? We did one down here where we ended up with, for number 4, we ended up first just bringing the 3 out front, and then we worked it out and got down to here. So I think it's actually kind of similar in how we're going to go backwards from this. Well, not from this, from this one. So where's this 2? Where do these 2's end up? Where does that 2 end up in this scheme? What do you think? What do you think, Travis? Just out here to the whole fraction? Yeah. Because it's applied to the whole fraction so that when we break into the subtractions, it goes out in front. Oh, okay. So it's just like, it's almost like puzzles. Just think of these as puzzles. Good. Alicia, perfect. Alicia had it too. Oh, God, look at this one. Oh, that one's not bad, actually. That one's not so bad. I see a lot of, what do we have? Addition. There's no numbers out in front, so no exponents or anything like that. And you're going to end up with it all connected to one log. And double check your rules. Like, how do you go from, why do we have these additions here? How can we simplify that with our rules? Bring your attention to the first rule. The first rule. And then once you get those, you can multiply them all again. Okay, someone in the chat, somebody at home, let me know what you end up with this after you simplify all of it. Because we have a 4, we have a 2, and we have a 5. All of the log terms were added together, so over here, the 4 is going to be multiplied to the 2. It's going to be multiplied to the 5, which is what? 2 times 5 is 10, times 4 is 40. Not bad. Not bad. Is that one a little harder? When there's 3, it's not too much harder, right? So you see, I mean, if this was like 20 terms, you would end up with log of each of the the index values just multiplied together. You get to the 40. And here's our last one of the day. This one's trickier. This is actually a step down from one of your homework problems. It's harder than this, but this gets you an idea. So when you get to that really hard, difficult homework assignment problem, look to number 4 from the condense. It's going to help you. But this, let's see what we have. We have a 2 out front. It hasn't been distributed. We have subtraction. And so I'd say simplify what's in the parentheses first, and then with that 2 out in front, how is that going to be combined in? So like I said, I'm gonna deal with what is in the parentheses first. It's subtraction. So I know it's going to be division. For x to y. And you know what? Here is where I'll let you know you can reduce right here. And I'm going to reduce this 4 and 2, and it ends up being 2x over y. Okay. So you can reduce midway. Once you get that fraction, you can reduce any fraction. Okay. So we're just condensing them now. It's just going the other direction. So it's the same pattern. And if we peek up here, we could see when we have subtraction. Yeah, it's just reversing it. So you're just looking for the other clue. Yeah, great. So what are we going to do with this 2? This is the only bit that we have left. It's kind of followed followed us all the way through. And we end up with log 2x and y up there squared. That's it. Now, you could go another step and say, well, this is really log of 2x over y times 2x over y. If you did that, it would just be like bonus points. And this would be 4x squared over y squared. Yeah, I don't think that makes it any much easier. So I would actually take either of these as an answer. Both okay. In fact, now I look at that, I prefer this. Don't go further. Because once we get to this step, we'll use the change of base that I'll teach you Tuesday. You won't need to make it more complicated. You'll be able to solve it. Easy. Schmeezy. 10 minutes left. Nice. All right, folks at home, give me on a scale from 1 to 5. How do you feel about these log laws? Any here too? Scale from 1 to 5? Probably got to practice a little more. Yeah. 4s, 5s. Okay. At home, we all have like 4s and 5s as well. Very good. Okay, I'm going to stop the video and just point out the homework for you, and we will end.